Oh, son of a nutcracker. Well, I had to replace this video because I lost the one where I actually started to tear this thing down to get into the head gaskets where I think the air leak is coming from. So I'm just going to kind of describe to you what I did here in this little compressor. To get at the head, you got to remove bolts here, same the other side, and then remove this pipe there and there. Be careful not to bend the fins. If those nuts are on there hard, just put a wrench on there and just shock it a little bit with a hammer strike. Not a hard hammer strike, just a little hammer strike. That little shock will take it off. And then once that's exposed, the head will be exposed, and it's just 4 M6 bolts. They just pop off quite easily. And then there's a series of reed valve plates, and you have to just clean the gasket material. And I just used a plastic scraper for that, just to clean up that material. Up next is how this thing works, and then we'll put it back together and test it all out. Okay, here is how this thing works. We've got ourselves, the head goes on top of here like this. Through this side here, this is the intake where air comes in, and then compressed air goes to the tank there. What happens is air comes into this side. The two sides are separate from each other, you see by this gasket liner here. This little reed valve here, it pushes down. I don't know if you can see that. Pushes down. So when the piston goes down, it pulls air in. Big deal. And then when the piston goes up, it seals off that little reed valve. And what it does on this second layer is when air comes out, it pushes up on this reed valve, which allows it to go up and into the tank. But the thing is that we don't want air from the tank to get back in. That's why we have this second reed valve. Air in the tank is going to be higher pressure, so it's going to try and push back, but that's going to end up putting this seal down on top of this reed valve. And so that's how it keeps pressure in the tank, and how it sucks air in and compresses it and pushes it into the tank. And then when the piston comes down a little bit, boom, seals that shut, opens the intake valve, does it all over again. Well, I couldn't find a service manual for this thing. So these head bolts, these are M6 bolts that are in here. I just looked up on the internet what will be the standard torque for an M6 bolt, regardless of whether coarse or fine thread, and these are coarse. And I am guessing these are a little bit more in a grade 3 bolt. They're probably a grade 5, maybe even a little bit more than that. So I'm going to do about 10 Newton meters. I think that's about 7 foot-pounds, something like that. And then torque them down and then just see how things go from there. I'll probably have to run it for a bit and then re-torque the head because of the new gaskets and all that jazz. Anyway, so you don't need to be watching me do that. So I'm going to put the rest of it together and then we'll fire this up. Well, you're wondering, how's it working, Don? Well, and it is working. It's working fine. But guess what? Where is it? Oh, there we go. It's still leaking. But it's not the head. There's a leak right here around, I put my finger over it. So there's a leak right on the gauge or something like that. So I got to put another gauge on there. Oh well, let's do that. Turns out it is this the little shut-off pressure switch. It is leaking, so I'm not going to try and repair that. Won't bother. I'll just get another one. So this video will be continued in a little bit. Bye now. Well, so I ordered had to order a whole new pressure switch unit, so that the relay inside there, just for this one little part which broke, but that's fine. I mean, this is a knockoff. The original Makita part was probably about 75 bucks Canadian, and this one was, I think, $29, and it seemed very popular. A lot of people use it, so we're just going to pop that on, take off that and pop that on, and see where we go from there. Just so I don't forget where the wiring is, I'm going to take it here. So obviously ground goes down to here. Cool. And then we've got, so this is going off the motor. So this is the motor side, this is the line side. So we have line neutral going here, and then we have neutral for motor here, and then we got line hot here, and boy, I hope that's not plugged in. That would, stick my tongue on that. And then hot for the motor there. There you go. So it's a little bit of a jigsaw puzzle getting this apart. Take the wires off first. That's cool. But then you can see underneath here, you need to spin the whole unit off this way, but that guy will be in the road. Okay, fine. Well, let's take that off. Well, the problem there is, if I spin this, it'll end up bumping into the shroud here. So it is a 1/4 turn of this whole unit, then spin that off, then I can start to spin this around. I think I might actually have to take this whole motor off. Oh, life is complicated here. Well, it actually turns out that this will work. So the idea is you turn this 90 degrees and then you get this guy off. And then I should be able to spin the whole unit. And it does, it kind of bumps the shroud a little bit, but that's okay. Now, obviously this pipe's going to get all twisted up, so I'll take it off. That should spin off and I should be good to go. Well, there's always a chink in the armor, isn't there? The these LiFo knockoff, starter relays. They have a nice little rubber boot which prevents dust from getting into the relay, which is great. But the problem is that they don't have a strain relief, and this cord is literally free hanging. So what I'm going to do is I'm going to put on a few zap straps to actually prevent it from pulling back through. But anyways, so it has a little benefit and has a little bit of a drawback. I got her all connected up. We got the regulator side on. We got the pressure relief valve here. Base is on. All the wiring's in place. Let's give her a shot and just plug her in. Ready for sparks? Oh, nothing happens. Better turn on the switch. Okay, she is still leaking. What the heck? Pressure's not going up at all. That's going into the tank. There's some kind of a leak. Wait a sec, I think it was... Okay, there it is. It appears as though... There it is. I gotta put a plug in. Okay, we're getting there. Okay, well, I've got the plug in the back, right back in there. So I got the plug in, I got the pressure relief valve in, the relay's on, the regulator's on, the, I don't know what this would be, regulator, no, it would be the cutoff switch is on. So let's power her up now. Well, we didn't see sparks last time, so I'm not expecting sparks. I hear quiet. And let's see if we can adjust this, guys. There. You can see pressure building, which is great. Let's see if we can see a building on the lower meter, so that's in-tank pressure, and external pressure. We'll just see what we might have to do. A little bit of adjustment. There's an adjustment screw here, and that is for the high pressure, the high cutoff. And then there's a low cutoff. Might have to do a little bit of adjustment there, we'll see. Don't want to get that tank greater than 140. And it's up to, what's it up to? Oh, it's getting quite high. I'm going to shut her off when she goes much higher. Oops, there we go. Oh, right on 140 on the nose. Okay, well, I think we're just going to button this up, and this job is done fixing the Makita pneumatic MAC700. Thanks everybody for watching. Please post your comments down below. I'm very curious how you get along with your repairs on your compressors, and what kind of stuff have you run into, and what kind of equipment you use and parts you get, whether you do OEM or the knockoff stuff from Amazon. Please, oops, I keep doing this wrong. Please click the subscribe button up here, somewhere up there. Boop, boop, boop. And yeah, leave comments. We'll talk. Bye now.